In this video, we're going to talk more about circles and angles, but in this video, we're going to talk about what happens if you actually don't know the center. So, what happens if I just have some random angles in my circle that are just formed by two chords that are not necessarily at the center? Or, how do I find angles that are outside the circle with a vertex on the outside that are formed by like tangent lines or secant lines in any of these ways? So we've talked about tangent chord angles. Those are different, just to be clear. With tangent chord angles, the vertex was on the circle itself, and those are pretty much like inscribed angles. You just take the arc and cut it in half. So that's not what we're talking about here. Also, we've seen circumscribed angles, which is formed by two tangent lines, but again, with these, you had to know where the center was. Because to find circumscribed angles like this, we were doing the fact that like these two add up to 180, and that's how you can find a circumscribed angle. But what happens if you don't know where the center is? So that's what we're going to get into today. Let's start with if the vertex is inside the circle, and then we'll deal with outside here in a second. They're pretty similar, actually. So if the vertex is inside the circle, like you're trying to find this angle here, but it's not a central angle. Remember, if it were a central angle, then that angle would literally match the arc. But in this case, it's not. So why don't you just take a guess, actually? If this arc right here is 70 degrees, and this arc right here is 30 degrees, and I know that's not really to scale, but what do you think x should be? Keep in mind, these two have to be the same because they're vertical angles. So like, what feels fair? It's probably thinking somewhere in between 70 and 30, because it's not perfectly a central angle, but it's kind of like a central angle. And that's exactly it. All you really do to find an interior angle like this, sometimes they're called chord-chord angles because they're formed by two chords. All you have to do is average the two arc measures, and that'll tell you what both of those angles are. The formula kind of looks like this, but if that confuses you, just think that you average the two arcs together. So the first intercepted arc plus the second intercepted arc divided by 2, you average them. And that tells you what that interior angle should be, angle 1. So, for example, I want to find x. Again, if this were at the center, x would just be 160, but it's not at the center. And if this were at the center, that would just be 35, but it's not. So instead, we just average the two arcs. So all you have to do is do 35 plus 160 divided by 2, and let's see what that is. So 195 divided by 2, which is 97.5. So that's what this is, 97.5. And this as well, because they're vertical angles, they have to be the same. Basically, it's like what's halfway between this and this. Let's try another one. I want to find angle x. Notice that on this one, if I average up 80 and 80, I just get 80. 80 plus 80 would be 160, and then divided by 2, it's 80. So that actually tells me, not only is this 80, but that's actually the center. If those two arcs are the same, and then both of these are 80 as well, then that actually is the center point. So I didn't really have to work that hard on this one, but anyway, that's how you can tell that it is the center. And then just for the record, let's say I wanted to find like this angle right here. All you would have to do is take 180 minus this, and then you can find that angle. All right, now let's talk about what happens if the vertex is outside the circle. It's actually very similar to what we just did, but instead of adding up the two arcs and dividing by 2, you actually just subtract them. So you take the measure of the big arc, subtract the measure of the small arc so that it stays positive. You got to do big minus small. And then divide by 2. So instead of adding, you subtract. This works for any of these scenarios. So if it's a tangent and a secant, if it's 2 tangents, or even if it's 2 secants. This will work. You just do big arc minus small arc divided by 2. Let's try a few. This is 2 tangent lines here. I know that arc ABC, so ABC, that's the big arc, is 190. And arc ADC, so the small one, is 170. I want to find x. So again, you just take the big arc minus the small arc and divide it by 2, which would be 20 divided by 2, which is 10. So this right here is 10 degrees, which is, again, not really scale, but you get the idea. Let's try one that's 2 secant lines. This one's a little tricky actually, because rather than trying to solve for the angle, I'm actually trying to solve for the big arc. But I can still use that same formula that we just talked about. So big arc minus small arc should equal, divided by 2 should equal this. So the big arc, which in this case is just t, minus 47 divided by 2 should equal this, which I know is 30 degrees. And now just solve for t. So multiply both sides by 2. And then add 47. And so t is 107. So this would be 107 degrees. All right.